Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about topic of derivatives of inverse trigonometric functions. Okay, so as you can see here, this is the formula that we have for the inverse trigonometric function. We have sine inverse x, cos inverse x, tangent inverse x, cotangent inverse x, secant inverse x, and cosecant inverse x. Okay, so today we will straight away look at the example. Okay, this is for example 1. So we'll try a few of this question. Okay, the question is y equals to 4 log x plus x power of e minus 3 secant inverse x. So we can differentiate directly using the formula dy dx equals to 4 times 1 over x ln 10 plus e power of x e minus 1 minus 3. The formula for secant inverse is 3 times 1 over modulus x times x squared minus 1. And then you just simplify the question. So you should get 4 over x ln 10 plus ex power of e minus 1 minus 3 over modulus x times square root of x squared minus 1. Okay, done for question A. Okay, we continue with example number 2. Okay, so this one, this time it will involve chain rule, as all this question is in terms of composite function. Okay, so right now we'll try the first question. Question A. Question A, y equals to secant inverse x power 4. Okay, number one here, what's important is to identify which one is the inside and outside function. So the outside function is this one, and this is the inside function. Okay, so you will differentiate the outside function first and then the inside function. Alright. Okay, so if we differentiate this, we will get dy dx equals to 1 over modulus x power 4 times square root of x power 4 squared minus 1. Okay, times this is the first. This is what you get if you differentiate secant inverse x, secant inverse, and then next you differentiate x power 4, you get 4x cubed. Okay, and then you just simplify, right? So you shall get 4x cubed over modulus x power 4 times square root of x power 8 minus 1. Okay, so from here you can see actually this is the first part, or what you get if you differentiate secant inverse, and this one is what you get if you differentiate the second one, that is x power of 4. Okay, next question B. Let's say we have y equals to 2 cos inverse x plus 1 over 2. Okay, so if you differentiate, you get, let's say this one y. So if you differentiate, you get dy dx equals to, so 2 just bring in forward, and then differentiate cos, get negative 1 over square root of 1 minus x plus 1 over 2 squared. Okay, alright, and then differentiate x plus 1 over 2, you shall get 1 over 2. Okay, so again, this is what important for this question is to identify which one is the inside function and which one is the outside. So in this case, this is the outside, and then this one is the inside function. So we always try to differentiate for chain rule. Always try to differentiate the outside function first, and then next is the chain rule. Next is the next is the inside function. Okay, next what you can do is you have to simplify this function. So cancel. Then this one you simplify, you should get negative 1 over square of 4 minus x plus 1 square over 4. Okay, and then simplify more, so you should get negative 2 over square root of 4 minus x plus 1 square. Okay, so done for question B. And then next, question C. Okay, let's say we have 4x power of ln 2 times tangent inverse x cubed. Okay, so as you can see here in this question, there is a variable and variable. So that it means that for this question we need to apply product rule. Okay, so first get to dy dx equals to first differentiate this one for x power of ln 2. So for ln 2 x power of ln 2 minus 1 times tangent inverse x cubed plus 4x power of ln 2 times, so this one for tangent inverse x cubed we should use chain rule lah. So 3 times tangent inverse x power of 2 times differentiate tangent inverse, you should get 1 over 1 plus x squared. Okay, and then you can simplify lah. Okay, so get 4 ln 2x power of ln 2 minus 1 tangent inverse x cubed plus 4x power of ln 2. I think we can write as 12. 12x power of ln 2 tangent inverse x squared over 1 plus x squared. Okay, so there you have it, the third question for example 2. Okay, so here we apply product rule and also chain rule.